Welcome back to Monroe Tutoring, and if it's your first time, well then welcome, and let's learn some stuff. So last time I spoke about stoichiometry. I did an intro to stoichiometry. This time we're going to take it up a notch, and we're going to have some other units involved. So let's start off with a question. Let's say you're being asked how many grams of carbon dioxide are produced from the complete combustion of 1 mole of ethane. So now let's look at that and just write down the information where it goes in the reaction like I taught you last time. So I'm given 1 mole of ethane. Let's say we have some sig figs here. So it's 1.00 mole of ethane. And I'm being asked how many grams are produced. So now I'm given moles and I'm asked for grams. Now, just like we did last time, we're going to take our given information, we're going to put it to the left. Again, if you haven't seen that video, make sure you check it out. That's the intro to stoichiometry so that we understand how to use the chemical equation. We have to make sure it's balanced. But we're going to go ahead and take this information, put it to the left, and we have 1.00 moles. And it's really critical to label what you have moles of. So we're going to write the C2H6 here so we know what we have and we know what units we have to cancel out. So I have moles of ethane and I want grams of CO2. Well, in order to cancel out moles of ethane, what do I need? I need something with moles of ethane in it. And I want to get to some information about CO2. Well, as I taught you last time, if we look at the chemical equation and we take the coefficient of the substance, of both substances, that's the ratio of the moles in this reaction. So in other words, I want to know about carbon dioxide and I have info about C2H6. So I'm going to write down my conversion factor, which is that for every 2 moles of C2H6, so 2 moles of C2H6, there are 4 moles of CO2. 4 moles of CO2. And so now I have some information that involves moles of ethane. So that means I can set up a parenthesis here and I can cancel out moles of ethane, getting me closer to my target. So moles of ethane are on the top. That means they have to go in the bottom. So I'm going to put this 2 moles of ethane in the bottom. That's 2 moles of C2H6. And then the other side goes in the top because I want to know about CO2. So that's 4 moles of CO2. Now, if I did this math and I plugged this in and I did 1 times 4 over 2, so that's just 1 times 2, I would get 2 moles, right? That would be the moles of CO2. And if that's what I was asked for, we'd be done. But they didn't ask for moles, they asked for grams. So we're going to keep going. Let's cancel out these units while we're here. Now, I have moles of CO2. I want mass of CO2. And as I taught you in a video, I think it was 2 or 3 videos ago now, with molar mass, when we want to go from moles to mass, we use the molar mass. And if you recall the units of molar mass, it's grams per mole. So that means we can go between grams and moles with that. So we have moles, we want grams. That means we need to know the molar mass of CO2. Okay? So I also taught you how to get molar mass, right? So if you don't know how to do it, check it out, but let's do it really quick right now. If we look at the CO2, we're going to ignore the coefficient for this part because we want to know the mass of a single mole of CO2. And so there's 1 carbon, and you have to look this up on your periodic table. Carbon is 12.01 grams per mole, and oxygen, there's 2 of them, so that's 2, and there's 16.00 grams per mole. So we get, that's 32 plus 12, that's 44.01 grams per mole. That's for CO2. And just like I taught you in the molar mass video, it's good to write this out as a conversion factor so that we can use it instead of having to memorize some formula. We just use a conversion factor and we can do it all in line like I taught you in my dimensional analysis video. So instead of writing it like this, I'm going to write out that 1 mole of CO2 is equal to 44.01 grams of CO2. I like to be a little bit redundant here and explicit with the labels on my units. so that when we're doing stuff like this, we don't lose track of what these molar masses are, and we just make sure that all our units cancel out properly. So now we have moles of CO2, we want grams of CO2, we have something that relates them both. So now let's go ahead and set up our next parenthesis, and we're going to put this in. If moles of CO2 are on the top now, where do I put 1 mole of CO2? That's the bottom, right? So down here is going to be 1 mole of CO2, and on the top is the other side. That's 44.01 grams of CO2. Close this up. Moles of carbon dioxide and moles of carbon dioxide cancel. The answer will be in grams of CO2, and that's what I'm being asked for, right? So you can just punch this into your calculator, but I'm pretty sure this is going to be easy because it's just 1 times 4 divided by 2, so that's 1 times 2, that's 2, times 44.01, so that's going to be 88.02. 88.02. I'm writing on a slant again, and that's going to be grams of CO2, and this problem is done, okay? So just remember, the coefficients in the equation can get us from moles of one substance to moles of another substance. Grams are not involved when we're talking about these coefficients. These are the ratios between the moles of the reactants and the products. When we're asked for something to do with grams, that's when we're talking molar mass. All right, guys? So if this helped, please give a like, follow, share, save this so you can review it later. And if you'd like to support me further, go ahead and check out my links so you can patronize me there. That helps me to continue making these videos for free. Thanks again, and I'll see you guys in the next one.